Hello, hello, hello. Uh, Hello everyone. So today we are starting with bridge course line. Previous class actually we started with few basic concepts of chemistry. We are continuing that one. It's a bridge course for your 11th standard to 12th standard. Very basic things about in which you have studied in 11th standard. We are going to continue that. I hope last class we have studied till rounding of numbers, if I am not wrong. So let me check whether my voice is clear or not. Yeah, I think I'm properly audible also. Okay, so let's continue with the class today. So here today we are let's start with some conversions. See, first conversions we have is degree Celsius to Kelvin. When something is given in degree, when the temperature, we know in basic units and measurements we have studied, degree Celsius, Kelvin is the SI unit of temperature. But in most of the cases, what we do is we use Kelvin in calculations, and Kelvin is the SI unit, but we say the temperature in degree Celsius. When the temperature is given in degree Celsius, how do we convert that into Kelvin scale? We have a formula for that conversion, that is Kelvin is equal to degree Celsius plus 273.15. But the thing is that sometimes calculation of this 15 becomes little difficult, like it involves more calculation. That's why instead of that, what we take is Kelvin is equal to degree Celsius plus 273. If you don't take 15 also, that's fine. Okay, so let's take one example. If in case 25 degrees Celsius is given, what is given? The temperature given is 25 degrees Celsius. And you have to convert this one into Kelvin scale. How do you convert this one into Kelvin scale? We know the formula. Kelvin is equal to degree Celsius, that is 25 degrees Celsius plus 273. So what is your answer? 298. So if 25 degrees Celsius is given, how will you convert that one into Kelvin? Not degree Kelvin, just Kelvin. For Fahrenheit, we use degree, not for Kelvin. So how do we convert? Just add 273 for that. It's very simple. So I think it's better to give one or two homework for this one. So take few homeworks. Homework. Convert to Kelvin scale. Convert to Kelvin scale. First one, 32 degrees Celsius. Second one, 44 degrees Celsius. And third one, 0 degrees Celsius. Okay, so convert this and let me know the answers in comment section. Now let's go to next conversion. That's conversion of degree Celsius to Fahrenheit scale. We have to convert degree Celsius into degree Fahrenheit. So which formula helps us to convert from degree Celsius to degree Fahrenheit scale? Anybody have idea? Please comment in the comment section quickly. Which formula we use to convert degree Celsius into degree Fahrenheit? So we have the formula degree Fahrenheit is equal to 9 by 5 degrees Celsius plus 32. 9 by 5 degrees Celsius plus 32 is the formula which is used to convert degree Celsius into degree Fahrenheit scale. Now let's take one example and check this one. Convert 37 degrees Celsius into degree Fahrenheit. So we know that from the above formula what we have, degree Fahrenheit is equal to 9 by 5 into degree Celsius is 37 plus 32. So 9 by 5 into 37, which will be equal to 66.6 plus 32, which is nothing but 98.6 degree Fahrenheit. Okay, is it clear? Direct, you have to substitute wherever it is required. Substitute that degree Celsius value, or in case Fahrenheit is given, if you want to calculate degree Celsius from that, just reverse the formula, rearrange the formula and calculate it. How will you rearrange the formula? Degree Celsius is equal to 5 by 9 degree Fahrenheit minus 32. So by rearranging, you can calculate like this. Let's solve one more question based on this one. Take 25 degrees Celsius and convert this one into degree Fahrenheit. Formula, what is the formula? Degree Fahrenheit is equal to 9 by 5 degree Celsius. What is degree Celsius? 25 is given plus 32. So which is 9 by 5 into 25 is 45 plus 32, which is equal to 77 degree Fahrenheit. 77 degree Fahrenheit. Okay, is it clear? I hope no doubt in this one. Conversion from degree Celsius to Kelvin scale and Kelvin degree Celsius into Fahrenheit scale. Fahrenheit scale you require very like less cases, but Kelvin is very important. Remember that. Now let's go to molecular mass. Tell me, what is molecular mass? What is molecular mass? How to calculate molecular mass? Molecular mass. When a molecule is given, for example, consider H2SO4, H2SO4. Okay, so we have H2SO4. Now we have to calculate molecular formula of H2SO4. For this, what I have to do? We have two hydrogen atom, 2 into atomic mass of one hydrogen. What is the atomic mass of one hydrogen? 1. 2 into 1 plus. How many sulfur atoms are there? One sulfur atom into atomic mass of sulfur is 32. Plus, next, 4 hydrogen atoms are there. 4 into atomic mass of hydrogen is 16. So what do you get? 2 plus 32 plus 64, which is equal to 98 U, or you can write 98 AMU. Okay, is it clear? So this is how we calculate molecular mass. You should know the atomic mass of all the atoms present, atomic mass into how many atoms are present, plus total number different atoms. So this total gives molecular mass. Let's calculate for one more molecule, molecular mass of one more molecule. Take C6H12O6. 6 into atomic mass of carbon is 12 plus hydrogen. 12 hydrogen atoms are there. 12 into, what is the atomic mass of hydrogen? 1 plus 6 into oxygen. What is the atomic mass of Oxygen 16. So 16 to 16. Total how much you get? 72 plus 12 plus 96, which is nothing but 180 AMU or just 180 U. This is how we calculate molecular mass. Now comes the important term, that is mole concept. This is very, very, very important, mole concept. So let's start with mole concept. Now, what is this mole? Do anybody know what is mole? What is this mole? We know it's a, what we can say, it's a unit to measure something. For example, if I take 1 dozen, what does that imply? 1 dozen. If I say 1 dozen of banana or 1 dozen apple, 1 dozen always represents 12 units. If I say 1 dozen apple, that means 12 apple. If I say 1 dozen pen, that indicates 12 pens. Dozen always represent how much? 12. In the same way, whenever I refer 1 mole, whenever we refer 1 mole, which represents 6.022 into 10 power 23. How much? 1 mole is equal to 6.022 into 10 power 23. This number is represented by the symbol Na. This is called Avogadro's number. What is the name given to this? Avogadro's number. Avogadro's number. So whenever you're asked what is 1 mole, how many particles or how many units will be present in 1 mole, what you have to say? 6.022 into 10 power 23 will be present. And what is the name given to that? Avogadro number. Okay, now let's take few examples for this one. If I write 1 mole of carbon atom, what we are taking? 1 mole of carbon atom. So what it represents? How many atoms are present in 1 mole of carbon atom? 1 mole of carbon atom is nothing but 6.022 into 10 power 23 carbon atoms. See, every time I cannot say 6.022 into 10 power 23 atoms. Instead of that, I say 1 mole of carbon. Okay, whenever 1 mole comes, what you have to keep in mind? It's Avogadro number of particles, 6.022 into 10 power 23 carbon atoms. And how much they weigh? They weigh 12 gram. 12 gram, not 12 AMU. 12 AMU is mass of one atom of carbon, or 12 U is mass of one atom, single atom of carbon. But 6.022 into 10 power 23 atoms weighs how much? 12 gram. Remember that unit, 12 gram. 12 gram is for 1 mole of atoms, not single atom. Okay, next let's take for sodium. If I write 1 mole of sodium atom, tell me how many atoms will be present in 1 mole of sodium atom? How many are present? Please answer in the comment section fast. Be quick. How many atoms of sodium will be present in 1 mole of sodium? They contain 6.022 into 10 power 23 sodium atoms. How many they contain? 6.022 into 10 power 23 sodium atoms will be there. And what is the mass of 1 mole of sodium atom? That is 23 gram. Is it clear? One sodium atom weighs 23 U or 23 AMU, whereas 1 mole of sodium atom weighs how much? 23 gram. 6.022 into 10 power 23 particles, sorry, atoms of sodium weighs how much? 23 gram. Okay. Now, take another one. 1 mole of H2O molecule. In 1 mole of H2O molecule, how many H2O molecules will be present? Listen to the word which I am using. In 1 mole of H2O molecule, how many molecules will be present? 6.022 into 10 power 23 H2O molecules will be there. Okay, H2O molecules will be there. And how much they weigh? 1 mole weighs how much? 1 mole of H2O weighs 18 gram. 1 mole of H2O weighs how much? 18 gram. And if the question is like, if the question is, how many atoms are present in 1 mole H2O. How many atoms are present in 1 mole H2O? I am not asking how many molecules are present in 1 mole H2O. What we have to calculate? How many atoms are present in 1 mole H2O? See, we know 1 mole of H2O, 1 mole H2O, this contains 6.022 into 10 power 23 H2O molecules. H2O molecules will be that. And in one molecule, if I consider single H2O molecule, one H2O molecule contains how many atoms? See, check this atoms. 2 hydrogen and 1 oxygen, right? So 3 atoms. In one molecule, how many atoms are there? 3 atoms are there. Therefore, in 6.022 into 10 power 23, we have 3 times 6.022 into 10 power 23 atoms. I hope this one is clear. This is nothing but 18.066 into 10 power 23 atoms will be there. Any confusion in this one? Number of atoms present in 1 mole of H2O. Okay, first calculate in one molecule how many atoms are present, and we have 6.022 into 10 power 23 H2O molecules multiplied with 3 atoms present. I hope this one is clear for you. Next, let us go to one. Let's solve one in terms of volume. If I say 1 mole of any gas, 1 mole of any gas, that may be hydrogen gas, that may be carbon dioxide gas, that may be oxygen gas. Consider any gases. 1 mole of any gas at standard temperature and pressure STP occupies 22.4 liter. How much? 22.4 liter. This is called molar volume. Molar volume. Whatever may be the molecule, whatever may be the gas, at STP, 1 mole of any gas occupies how much? 22.4 liter of volume. Okay. Now let's take one question and solve it. Take the question. Calculate the mass of first one, an atom of silver, second one, a molecule of carbon dioxide. So if we solve this, like almost mole concept will be clear for us. So calculate the mass of an atom of silver and a molecule of carbon dioxide. First, let us solve the first question. An atom of silver. We know 1 mole of silver atoms. 1 mole of silver atoms weighs how much? 108 gram. 1 mole of silver atom weighs how many grams? 108 gram. So in 1 mole, how many atoms are present? 6.022 into 10 power 23 atoms will be there. These many atoms weighs 108 gram. So therefore, what is the mass of one atom? Mass of one atom is equal to 108 divided by 6.022 into 10 power 23. So this is nothing but, how much do you get? 1.79 into 10 power minus 22. So this is mass of one atom of silver. Total 6.022 into 10 power 23 atoms weighs 108 gram, and how many particles will be present? 6.022 into 10 power 28. Total they are weighing 18 gram. So to calculate 1, for 1 would have to divide total mass divided by number of particles or atoms present. That gives the mass of one atom of silver in grams. Okay, so this is answer for first question. And what is the second question? A molecule of carbon dioxide. To calculate mass of a molecule of carbon dioxide, what do we have? Second one, 1 mole of carbon dioxide. 1 mole of carbon dioxide weighs how much? 44 gram. That is molecular mass. Molar mass is 44 gram. That means 1 mole of CO2. In 1 mole of CO2, how many CO2 molecules will be there? Yes, 6.022 into 10 power 23 CO2 weighs how much? 44 gram. Therefore, 1 molecule of CO2 weighs 1 molecule of CO2 weighs how much? 44 divided by 6.022 into 10 power 23. So this is nothing but 7.307 into 10 power minus 23 gram. This is mass of one molecule of carbon dioxide. 6.022 into 10 power 23 carbon dioxide molecules weighs 44 gram. What is the mass of one molecule? 7.307 into 10 power 23 gram. So this is how you will calculate molecular mass. molecular mass of one atom. I hope there is no confusion in calculation of moles now. One atom, mass of one atoms and all. So it's a very simple one. Next we have to go to one of the important, very important term, that is stoichiometry, which is the next concept we have to start. Stoichiometry. Stoichiometry. So what is the stoichiometry, or you can say in simple, stoichiometric coefficients? What are the stoichiometric coefficients or stoichiometry? We know balancing chemical equation. We have learned that from 10th standard. Balancing chemical equation. For example, take any equation and write the balanced equation for that. CaCO3, calcium carbonate, reacts with HCl and it forms CaCl2 plus H2O plus CO2. Check whether the reaction is balanced or not. Is the reaction is balanced? No, it is not balanced. See, this side we have two hydrogen atoms, but this side we have only one hydrogen, and chlorine is also 2. So what I can do, I'll multiply it with 2. You already know methods of balancing chemical equation. Either follow ABCD method or hit and trial method for stoichiometric coefficient calculation. These numbers which are present are called stoichiometric coefficient. What this says, what this indicates, this stoichiometric coefficient, this indicates, see, 1 mole of CaCO3, how much? 1 mole of CaCO3 reacts with 2 moles of HCl. For 1 mole of CaCO3, how much amount of HCl is required? 2 moles. And always remember, you have to balance the reaction before writing this stoichiometry. If you don't balance the reaction, then you will get wrong answers. 1 mole of CaCO3 reacts with 2 mole of HCl to form 1 mole of CaCl2, calcium chloride, plus 1 mole of water and 1 mole of carbon dioxide will be liberated. So this is the actual stoichiometry in terms of moles. If you want to say in terms of mass, then how will you say mass of calcium carbonate? What is the mass of calcium carbonate? 40 gram. Sorry, 40 is for calcium. 40 plus carbon 12 plus 3 into 16. So I am going to write complete molecular mass here. It is 100 gram. 100 gram of calcium carbonate requires HCl, 2 times HCl. See, HCl, mass of 1 HCl is 36.5. Chlorine 35.5 plus hydrogen 1, 36.5. But how much do I have? I have 2 moles. 2 moles weighs how much? 73 gram. I hope this is clear. 36.5 plus 36.5, that is nothing but 73 grams. And CaCl2, calcium chloride is 111 gram mass of calcium chloride, and water is 18 gram, and carbon dioxide is 1 mole of carbon dioxide is 44 gram. This is stoichiometry in terms of which one? Mass. In terms of mole or in terms of mass also you should be able to say. In case volume is given, you should know volume also. We have studied in mole concept about volume. Now based on this, we have to solve questions. Okay, so based on this one, we have to solve questions. And always remember here, if whenever I take 100 gram of calcium carbonate, it requires how much gram of HCl? 73 grams of HCl. If I have 72 grams of HCl also, the reaction will not complete. The required amount of product formation will not take place. Okay, less amount of product will be formed because HCl is present in less quantity. For 100 gram of calcium carbonate, we want 73 gram of HCl, but 73 gram of HCl is not there. Imagine we have only 72 grams, so 1 gram is less. In this case, what happens? Some amount of CaCO3 remains unreacted. Some amount of CaCO3 remains unreacted. So here HCl present in less quantity than required, and it is controlling the product formation. Which one is controlling the product formation? The one reactant which is present in lesser quantity is controlling the product formation. That reactant which is present in less quantity and controlling the product formation is called limiting reagent. That's our next topic. After solving one question, we are going to take limiting reagent. Okay. It is a state board. Smita, yes, it is state board. Hi, hi. Okay, it's state board only. And it's everything which we are going to study is from NCERT textbook. Okay, bridge go in 11th standard we have few things we are learning the basics, then we are coming to very important part, that is 12th standard part. Okay, stoichiometry. Now see, take the question. After solving one question, let's go to limiting reagent. Calculate the amount of water. Calculate the amount of water in gram produced. Amount of water in grams produced by the combustion of 16 gram of methane. By the combustion of 16 gram of methane. This is the given question. Now, what is given here? Calculate the amount of water in grams produced by combustion of 16 gram of methane. Methane is undergoing combustion. What is the formula of methane? CH4. It is undergoing combustion, means it reacts with oxygen, and on combustion what products are produced? CO2 plus H2O. And I told you always we have to write balanced equation. We have to balance the stoichiometry first, stoichiometric coefficients first. Balance the equation. While balancing, what do we get? 2O2 and 2H2O. Now the reaction is balanced. See the question. What is given? Calculate the amount of water. What we have to calculate? We have to calculate the amount of water in grams produced by combustion of methane. Produced by combustion of methane. So we have won a relation between H2O and CH4. From the given equation, in the given equation, what do we have? What do we have in the given equation? One mole of CH4 reacts to produce 2 mole of water. This we get by balanced chemical equation. Okay, 1 mole of CH4 produces 2 moles of water. And what is the mass of 1 mole of CH4? 1 mole of CH4 weighs 16 gram. Mass of CH4. 1 mole of CH4 weighs how much? 16 gram. And it is producing how much? 18 into 2. That is nothing but 2 times 18, because 2 molecules of waters are being produced. 2 into 18, which is equal to 36 gram. So how much? In the question, we are asked to calculate combustion of 16 gram of methane produces how much amount of water. Here, after balancing directly, we got the answer. 16 gram of methane is producing how much gram of water? 36 gram of water. No need of further calculation. Okay, here directly we got the answer. Is there any confusion in this one? I hope there is no confusion, because it is very, very simple one. Okay, now let's take the next question. Take the next question. How many moles? Second question. How many moles of methane are required to produce 22 gram CO2 after combustion? How many moles of methane are required to produce 22 gram CO2 after combustion? This is the question. And again, write the formula, equation. Combustion of methane, CH4. Just above we have written 2O2 forms CO2 plus 2H2O. And write its stoichiometry. See which stoichiometry I require. I'm not going to write all the stoichiometry. Whichever I require, only I'll write that one. I want the relation between methane and carbon dioxide. Methane, 1 mole of methane producing 1 mole of CO2. And what is the mass of 1 mole of methane? 1 mole of methane is weighing 16 gram, and 16 gram of methane is producing how much gram of CO2? Mass of carbon dioxide. Carbon is 12, oxygen is 16 into 2 oxygen atoms. Total it is 44 gram. 16 gram of methane is producing 44 gram of CO2. And one more thing. And what is the relation given? How many moles of methane are required to produce 22 gram of CO2? See, I have from the relation here, 1 mole of CH4 is producing how much gram of CO2? 44 gram. 1 mole CH4 is producing 44 gram CO2. Therefore, X mole CH4 required to produce 22 gram CO2. I don't know how much mole of CH4 is required. Just cross multiply and calculate it. Do the cross multiplication. 22 is equal to 44 into x, or I can write x is equal to 22 by 44, which is equal to 0.5. Okay, this is how by using stoichiometry you'll calculate amount of different substance formed. First we require, what we require is, we require main reaction, balanced chemical reaction. After balancing the chemical reaction, then we have to calculate how much amount is consumed and write the stoichiometry of that one and complete the given question. Any doubt in this one? It's very simple. If you understand mole concept is very easy compared to all other topics. Next, let's go to last topic, that is limiting reagent. Limiting reagent. I'll explain this limiting reagent in very simple words. First, let's take general example. After that, let's go to any chemical equation and reaction with that. Limiting reagent. What is limiting reagent? Imagine I have a box. What we have? We have a box. Okay, in this box I have few, imagine I'll place how many, 5 pink balls are there. Okay, 5 pink balls are there and 3 orange balls are there. How many orange balls are there? We have 3 orange balls. 5 pink balls and 3 orange balls are there. Now, here you have to pick balls. How many balls you have to pick? At a time you can pick 2 balls. But we have one condition. Whenever you are taking, you have to take 1 pink and 1 orange balls. Whenever you are taking, you have to take 1 pink and 1 orange ball. So how many pairs I can take? Since I have only 3 orange balls here, 1 pair, second and third. I can make only 3 pairs. Can I pick more? No, because the condition is I have to take 1 pink and 1 orange. Here we are left with no orange balls. We have only pink balls. 2 balls are left. I have 1 pair, but I cannot pick them because the condition is not satisfying. Here, though extra pink balls are present, I cannot take the pair out of the box because orange balls are present in less quantity. Though I have extra balls, but I don't have orange balls. So pair making is controlled by which colored balls now? Orange colored balls. Orange colored balls are present in less quantity than the required one, and they are limiting the group formation. In the same way, in case of chemical reactions also. Example, I'll take formation of ammonia. Take the formation of ammonia. So how ammonia formation takes place? Tell me the equation for ammonia formation. Anybody? You can answer in comment section. Be quick. How formation of ammonia? Ammonia, formula of ammonia is NH3. How formation of ammonia takes place? N2 plus H2 gives NH3. Whenever you write, make sure you are writing balanced chemical equation. So balance this equation. 3H2, 2NH3. Now it is balanced. Okay. So how can I write the stoichiometry of this one? How can I write the stoichiometry? Nitrogen. What is the mass of nitrogen? 14 gram. 14 into 2. That is nothing but 28 gram of N2. Hydrogen. How many hydrogen are present? 3 into 2. 6 hydrogen atoms are there. 6 into mass of hydrogen is 6 gram. And nitrogen NH3, mass of ammonia, 1 nitrogen is there. Nitrogen is 14 plus 3 hydrogen. That is nothing but I'll write here only 14 plus 3 hydrogen atoms into atomic mass of hydrogen is 3 only. Multiply it with 2 because 2 NH3 molecules are there. And what is the total? 17 into 2, 34 gram. Okay, this is the stoichiometric ratio. Now, take one question based on same equation. See, always remember whenever I have 1 mole of N2, it requires 3 moles of H2. If I have 2 moles of H2, then complete product formation. Product will be formed, but not 2NH3. Less amount of product will be formed because hydrogen is present in less quantity there, and that limits the formation of product. That's why hydrogen is called limiting reagent. And the one which remains in excess, more amount, is called excess reagent. Okay, so based on this, let's take one question now. Take the question. Uh, 50 kg, or let's make it a little bit simple. Okay, I hope you understood about limiting reagent. First, let's start with simple example. Consider the question. 3 gram of H2, 3 gram of H2 reacts with 29 gram O2 to form H2O. 3 gram of H2 reacts with 29 gram of O2 to form H2O. What we have to calculate? First one, which is limiting reagent, and second one, calculate maximum amount of H2O can be formed, and third one, amount of reactant left unreacted. Amount of reactant left unreacted. This is what we have to calculate. And what is given? 3 gram of H2 reacts with 29 gram O2. First, let us write the equation. This is for formation of water. H2 plus O2 forms H2O. Balance the equation. This is the balanced equation. According to this one, how much gram we have want the relation between O2 H2O2. See, according to this one, 4 gram of H2 reacts with 32 gram of oxygen to form how much gram of water? 36 gram of water. Okay, this is the relation between all these two reactants and one product formed. And what is given in the question? 3 gram of H2 reacts with 29 gram O2. How much gram of H2 we have? 3 gram. And it is reacting with how much gram of O2? 29 gram of O2 is present. Now, see, from the equation we have 4 gram H2 requires 32 gram O2. Therefore, 3 gram of H2 requires X gram of O2. Calculate it first. How much gram of O2 is required? For 3 gram of H2, cross multiply. X is equal to 32 into 3 divided by 4. Do the cross multiplication and calculate it. 32 into 3 divided by 4. We get 23.5 something. Wait a minute. Let's check. How much do we get? Calculate fast and let me know. 32 into 3 divided by 4. Yeah, it's 24. 24 gram of O2 is required. See, for 3 gram H2, how much gram O2 is required? 24 gram. But in the question, what is given? How much gram of O2 is that? 29 gram of O2 is that. How much gram of O2 is that? 29 gram. For 3 gram, only 24 gram is enough. But I have 5 grams in excess quantity. 5 grams of O2 is present in excess quantity. Remember, so O2 is excess reagent. Check the question. What is given that? In the question, the first thing is, which is limiting reagent. Oxygen is remaining extra. It is excess reagent. So, which should be the limiting reagent? H2 is the limiting reagent. It is present in less quantity because oxygen is remaining more. It is remaining extra after reaction also. When 3 gram of H2 is consumed, it reacts with 24 gram of O2. We left with 5 gram extra of oxygen. So it is excess reagent. If oxygen is excess reagent, another one should be the one hydrogen is limiting reagent. Okay, and next continuation of the question is, calculate the maximum amount of H2O can be formed. Always remember, product formed depends on limiting reagent. See, here we have checked pair formation depends on the balls which are present in less quantity. In the same way here also, hydrogen is limiting reagent, product form depends on limiting reagent. So based from the stoichiometry, what we have? H2 and H2O. Take that stoichiometry because limiting reagent is H2. 4 gram of H2 gives 4 gram H2 gives 36 gram H2O. 4 gram of H2 gives 36 gram H2O. Therefore, how much gram of H2O is given? 3 gram of H2 is given. How much gram of H2 is given? 3 gram of H2 gives how much gram of H2O? X gram H2O. Again cross multiply and calculate. X is equal to 36 into 3 divided by 4. So 36 into 3 divided by 4. 36 into 3 divided by 4. which is nothing but 27 gram. 27 gram of H2O is formed. Is it clear? So how much gram of H2 is formed? Sorry, H2O is formed 27 gram. Always product form depends on limiting reagent. And last question is, third question, amount of reactant left unreacted. See, if 3 gram of hydrogen reacts, it requires only 24 gram of oxygen. And how much oxygen I have? Total I have 29 gram of oxygen minus reacted. Total amount of excess reagent present minus reacted amount, that is 24 gram, which is equal to 5 gram. This much remains unreacted. This is how you will solve the questions based on limiting reagent. So this is about stoichiometry and mole concept. I hope all the concepts are clear to all of you. If you have any doubts in any of the topics, please let me know in the comment box so that I'll answer your questions and you will get the PDF of all these discussed topics. And from next, so this is the basic things which we require for 12th standard to start 12th standard chapter. We are starting with solutions from next chapter, and I'll make it very simple for you to understand. So stay connected and learn in easier way. Till that time, have a nice day. Bye bye.